Welcome to Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker. Unfortunately, there's no Kaushik Gopal today. We miss you, Kaushik. Welcome to episode number 16. So this is our third installment of the mini fragment episodes. Again, they're ranging anywhere from 7 to 20 minutes or a little bit longer. This time it's my turn. Kaushik is hanging out on the couch, relaxing, sipping orange juice, having a good old time. Anyway, today we're continuing the discussion on going through the items on the book of Effective Java by Joshua Bloch. Again, this is the second edition of the book. You'll probably hear us repeat that a few times throughout these initial fragment episodes. So we're just going to hop right into it. Last week, Kaushik covered item number 1. This week, it will be talking about item number 2. And item number 2 inside of Effective Java basically states, consider a builder when faced with many constructor parameters. Now, we've all been in the situation where you are building a class and it doesn't take any parameters, so you have the default constructor's there, you don't have to declare it. Then all of a sudden you need a constructor for whatever reason, and your class needs maybe a order class and needs an order ID, and you have to provide that order ID in a constructor. Before you know it, as the requirements of your applications continually grow, you start adding more and more items to this constructor. And we ran into this a lot over when I was working with MyFitnessPal. And it's amazing that Joshua Bloch actually gives the example in nutrition facts inside of the book. So if you're reading along with the book, you'll see he talks about nutrition facts. So if you're building something that requires certain nutrition statistics or whatever, you'll see that certain things inside of this nutrition facts class are required in the constructor. So long story short, when you start having a lot of parameters in your constructor, you start having various different overloads. So one constructor will have one parameter. The next one will say, hey, well, this time this one needs 2, this one needs 3, but in the special edge case, we need 8 constructor parameters. And hey, since this class has 16 different values, we're also going to provide, or 16 different fields, we're also going to provide a huge constructor with 16 different parameters. And what ends up happening is you have all these different constructors, and it's hard to tell which one you should use, which one you should not use. Is that value on that third constructor you're looking at, is that really required? What if I don't supply those values and someone calls an accessor or a mutator? Is something going to blow up that I don't know about? The invariance in there is not really, it's not really concrete. So it's really hard to understand what's really needed. And so this is known as the telescoping constructor pattern. So you just think of it as the constructor just getting bigger and bigger and bigger. It's just telescoping larger and larger and larger. And so that's one of the issues that we start having with the many different constructors that we have is. And so what we need to get back to is item 2 in Effective Java gets back to creating and destroying objects. So here we're talking about creating an object again. We're using constructor. So the problem we're trying to solve is how do we create this object? We can do it with the constructor with all these parameters and this telescoping constructor problem. But the problem is we have too many constructors and it starts to get unwieldy. At that point, we start running into issues with that is that it's just harder to write client code because we have all these constructors. It's harder to consume it. So if you are going to be building a new feature of an application, you need to use this object that has 20 different constructors or even 10 or even 5. It's hard to understand which one you should use. Sometimes you're left wondering, do I need those values or not? And another thing is the long sequence of parameters can cause really weird bugs at times. You may be missing something. You may have an extra value in there. You also may accidentally reverse 2 parameters on accident. So for example, maybe you have 2 integers in a row inside of that parameter list, and maybe one is age and another one is height in centimeters or something like that, and you may flip them on accident. So you can cause some really weird bugs inside of your application because of that. So let's assume maybe the constructor pattern isn't perfect because you have all these values. So another pattern that people usually rely on a lot is also the JavaBeans pattern. And all that is just basically a POJO, a plain old Java object, where it uses typicals, getters, and setters. And now, I've used this a lot before, and I've been with a lot of companies that have used this. Now, according to what Joshua says, and I've seen before, other problems that can happen in this regard when you use the JavaBeans pattern is you'll get inconsistencies partway through your construction. Maybe sometimes you need this value, sometimes you don't. There's no way to really enforce consistency upon creation of these objects. And so what it really does, it precludes it from making the class immutable, meaning that it can't be changed once it's set up. So sometimes we want to create an object and that's just the way it is. We don't want to change it. We want to leave it the way it is, and we don't want to allow people to change it. So we want it to be immutable. So if we're using just typical beans, the getters and setters, also known as accessors and mutators, we can run into some issues there if we want to make the class immutable. So now you can possibly freeze the object another way, but that also becomes very buggy because then you're introducing state variables inside of your class, and it just can get real messy. Now we also see another method if we don't use the bean method, which is what we actually see inside of fragments, and we see the new instance method. And so we see new instance. What you could do with this is just create a static method. The one thing you get with this is you really don't get a lot of compile time error checking if something is wonky with the default constructor not being present or valid. So I've run into that before. I don't have a default constructor because maybe I've implemented parsable on the class and I forget to implement it and I run the app and all of a sudden it just blows up because there's no default constructor and all kinds of stuff just kind of ends up happening. Also, you need to start checking for instantiation exception, which can kind of be really ugly and inconvenient at times. So in short, effective Java states that new instance can break compile time exception checking, which is a valid point. So Joshua's solution inside of effective Java is to use builders. A lot of you may be wondering, well, what is a builder? What is he talking about? Now, let's take this back to the Android paradigm. Think about Android for a second. What class in Android uses builder all the time? And the first one that came to my mind was the alert dialog. So you can use the alert dialog.builder. How many dialogs have you built that are just simple yes, no dialogs? Do you want to continue? Yes or no? Or has just a cancel button, or you just want to show a simple dialog. You've probably used alert dialog.builder. This is an example of the builder pattern in use. So the builder pattern uses a static member class named builder with a minimum of one method called build. It allows you to build an instance by chaining calls together like, let's just say, if you remember the alert dialog, we said alert dialog.builder.set title, .set message, .set positive button, set negative button, .build, and then we could build everything together. So it allows you to decide what you want to put in and what you don't want to put in. You can also provide a couple of required values inside the builder's constructor that you may always want to be present to ensure that the method is invariant when it runs, meaning that there are certain use cases that will always be true when the application is running. Now, that may be something you provide through the constructor. So the key thing is, the nice part about the builders is that it's easy to write, and more importantly, it's just easy to read. The builder pattern simulates named optional parameters as found in other languages like Python and so forth. So again, the main place you're going to find this in Android is if you look at the alert dialog class. There's other locations. You'll probably find it throughout the SDK, riddled here and there, but the one that most people are going to be familiar with, in my opinion, is going to be the alert dialog.builder class. Now, the thing with the builder is it's kind of cool because you can actually take the builder and pass this builder in as maybe if you create a builder interface like builder of T, and then you can actually have your static member class, which is the builder, implement that interface. And that means you can start passing around this builder of T to do something for you. So you could have like an abstract factory that uses a builder of T. Of course, you're using generics to start building out your objects. The class accepting the builder is usually constraining like the type argument. So that's how you could kind of work with that using a bounded wildcard type. You just need to make sure that you're using an interface in the builder itself so that you have, again, builder of T and it has a build method on it and so forth. And so you can use an abstract factory to create various different instances that you may not need to know what it's creating. It just knows that it has a builder. It's creating something of T itself. So now, builders aren't perfect. They do have problems of their own. Nothing is a silver bullet solution. So a couple problems that we have with builders is they do require a little bit more of ceremony. You got to write more code to write the builder and to consume it sometimes. Sometimes you just want to new up an object and you're done and you're off to the races. The builder requires you to instantiate a builder and start setting values, call the build method. So there is a little bit more of ceremony. Another thing is the builder can also be a resource hog if it's doing too much, and it can slow down if not profiled in high performance areas. Now, this is very rare in my findings. If you're building a line of business application where you have a couple of forms, you're accepting data, maybe you're just building some type of alert dialogue type or a simple dialogue of any fashion, or nothing too complex. It's not high performance. You're rarely going to run into these issues where it's performant. And again, we are in an embedded device or an Android devices, even though some of them are powerful. We always have to plan for them to be very resource constrained. So I can't say that I've ran into this personally on Android, but it's still something that you do need to be aware of. So even if you're just running, server-side Java or even just Android in general, you want to make sure that you're not doing something that's just insane inside of the builder, like, calculating some factorial of some weird number. So another thing is it could create a problem with your dependencies, could cause problems with your unit tests. So one of the problems is you want to make sure that if you have your builder needs a dependency on some external resource that could be intensive, maybe need IO bound or anything like that, you want to make sure that you're basically abstracting that behind another interface inside of your builder, so you can actually implement some type of mock or anything like that inside of your unit test. So that's one thing that I've ran into when creating my own builders as well. So that about wraps it up. It's a pretty short one today. The build pattern, it's a good choice. And when you're designing your classes, or which you start having a lot of constructors, it's time to take a step back and think like, should I implement a builder for this? Is this a proper use case for the builder? Do I want to make this class immutable? There's a lot of questions you should ask yourself. But anytime you get to the point where you have a lot of constructors, a lot of arguments in those constructors, take a look back and think, hey, would a builder be better for this? You don't have to go down the route of saying, hey, that your class is completely immutable, meaning that it can't be changed after you've created it. Maybe you just want to create a builder to make it easier and more clean to chain the methods together so it reads a lot better. For example, if you're creating something in the nutrition space and you want to create some type of nutritional value builder, such as Joshua has inside of the book here, you might say something like nutritionalvalues.builder, and you want to add the protein, the carbs, and the vitamin A and the potassium. You might say nutritionalvalues.builder protein, 12, maybe it's 12 grams of protein, carbs is 15 grams of carbs, vitamin A is 11 grams or whatever the measurement on vitamins typically is, potassium, 22 grams or whatever, build. And then I have a object, which is my nutritional values object that I can use. And maybe next time I'm building it and I only care about micronutrients, so now I'm only going to worry about micronutrients, or the next time I build it, I'm only going to worry about macronutrients, which are different types of nutrients inside of nutritional items. So again, take a look at your constructors, see what you think, and just always think in the back of your mind is, hey, could I use it? Would this be useful as a builder for myself and as for the other members on my team and for the future consumers and maintainers of my code? Hope that helps. We'll see you guys next time with item number 3.